Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 203 of The Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of The Observer's Notebook, and also the coordinator of the training program within the ALPO. Thank you for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers, also known as the Strolling Astronomer. This podcast depends upon donations from you, our listeners, to keep it going. If you enjoy what you hear in the podcast, you can donate to it via Patreon. So you can start off by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can find out more by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership begins at only $22 a year. Find out more at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. If you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now, episode 203 with Roger Venable, and we're going to talk about Mars as it reaches opposition. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And today we have with us Roger Venable. Welcome back, Roger.
Thank you. It's good to be here.
Yeah, it's been a while now. Roger's the coordinator of the Mars section for the ALPO. Why don't you give us a little bit of background about yourself before we start talking about Mars and the section?
All right. Well, I am a retired physician. I haven't done medicine for the last 4 years after something like 44 years of licensed practicing in family medicine and in emergency room medicine. And I no longer image Mars, sometimes look at it recreationally. I gave up imaging Mars probably 30 years ago.
Oh, wow.
Back in the days of Don Parker and so on. I've been an ALPO member since 87, so I guess that makes it 38 years now. And I mostly do occultations. I'm vice president. Actually, I'm acting president now of the International Occultation Timing Association. I'm actively engaged in that type of observation.
Oh, we are recording this on January. What's the date today? January 13th, and there's an occultation tonight.
Yeah, that's right.
Yeah. So, are you gonna be observing that? No.
There are a couple of things. First of all, it's cloudy in the southeastern U.S., but there are usually a number of occultations every night, and I'd look at the ones that have good cloud forecasts and look at the ones that are nearby, so I don't have to drive too far. Okay. And I actually am a mobile observer, and I try to set up a number of telescopes along a highway, typically. Oh, okay. And that way I'll get not only an occultation recorded, but I'll have several occultations that give me a profile of the shape and size of the asteroid and localize it in space extremely accurately.
Oh, my. I will have to do a podcast on that.
Yeah. So actually, the ALPO doesn't have a branch that does occultations, but it's solar system research.
That's right. That's right. Yeah. Now, how did you get involved with the ALPO?
Well, that's a good question. I don't have a really good answer. I think I'm the kind of guy who always wanted to be associated with other amateur astronomers, and didn't know how to do it. And I remember, if I have this right, it was in October of 1979 in Sky and Telescope. There was an article about how amateurs needed to join organizations that do science and band together, and ALPO was one of the organizations they emphasized, as well as the International Occultation Timing Association and a few others, and I procrastinated then for 8 years before I actually joined.
Oh my!
But I started observing through a small telescope when I was 10.
Okay.
So.
All right. So it's been a passion for a while.
Yeah. Whole life.
Yeah, I hear you. So give me an overview of the Mars section that you coordinate.
Well, the section doesn't have a bunch of sort of important people, really. I mean, I think anybody can do all that I do. I collect, people send me voluntarily their images, and I file them in the Mars archive of ALPO, and we've probably gotten about 1,000 images so far this apparition.
Oh my.
We generally get more than 2,000 a year, and Jim Melka helps me by coordinating some things on the ALPO website about Mars. He particularly likes to put particularly interesting images on the website that show dust storms or maybe peculiar clouds and so on. And that's a help to me. And Jim also is interested in some research on Mars and occasionally does some research himself. And I mostly review images and point out imaging features, interesting features on them to the observers. I try to correspond just a little bit with the observers and so on. We have a place to store images online on the group's IO, and it's called the Mars Observers. And no capitals, and it's one word, Mars Observers.
Okay.
And if you were to go to Group's IO, you could search for that group, and you'd find the Mars Observers. And it's mostly for people who draw Mars or image Mars, people who want to upload their images to that website to share them with other observers.
Okay. Well, the ALPO website also has quite the image catalog as well.
Yeah. It does. I think there are fewer on the ALPO website, but that's right.
Okay. Yeah, it's recently been updated, so yeah, I'd like to have people go there as well. So the reason we're talking is Mars is rapidly approaching opposition. In fact, this podcast is going to get released on the 15th, and on the 16th of January, Mars is at opposition, and that is when it's its closest approach to the Earth on this particular apparition.
Well, almost. You're the first person who's brought this up, believe it or not. But yes, the 16th is opposition, which means opposition date is when it's, there are a couple of ways to define opposition, but it's directly opposite the sun in the sky. Just that's close enough. But its closest approach to Earth was actually yesterday.
Oh, okay.
And the reason for that is that Mars has an elliptical orbit, about 10% elliptical. In other words, one dimension across the orbit is 10% greater than the other dimension. Earth's orbit is relatively round. And so, as Earth overtakes Mars in its orbit, as the two go around the sun, Earth is on the inside track, so it goes faster and it passes Mars. When the Earth is directly between Mars and the sun, we call that the opposition of Mars, which means it's opposite the sun. But if Mars is on the part of its orbit where it's moving farther from the sun on this elliptical orbit, then the closest approach will be a few days before the date of opposition.
Okay.
If the opposition occurs at a time when Mars is on that part of its orbit. And that's what's happened this year, and closest approach was yesterday.
Oh, okay.
So,
all right. Well, like I said earlier, you're the guy that knows everything about Mars. So
yeah.
Perfect. Okay. Now, how large does Mars appear at this apparition?
Well, it's about 14 and a half arc seconds in diameter. That's much smaller than average for Mars at an opposition. Now, at times far from opposition, Mars gets a lot smaller than that. But at opposition, that's the time when everybody wants to look because we're closest to Mars, near it in its orbit and so on. And you can see more detail because it's closer. So, right now is a really good time to be looking at Mars, and we'll be getting a lot of images. I'm probably getting about 10 or 12 a day right now.
Oh, great. Now, how many active observers do you have in the section?
Well, I don't count them, but I think we, worldwide, there are probably more than 150 who, who share their images. There are probably more observers than that, but those who share their images in the image storage places, like the ALPO, are probably over 150. And of those, I would guess that 100 of them contribute to the ALPO.
Okay, so we have a decent number of active observers.
Yeah.
Okay, so what type of equipment would you recommend people use that want to observe Mars?
Well, if one is new to observing Mars and is new to astronomy and wants to see Mars, most people start with a small telescope, sort of like, your first home or your first car. You don't buy a Mercedes, the first car, usually. And so the way to start is just to look and see what you can see with any instrument you have. And with binoculars, it'll just look like a bright orange star. And with a small telescope, a couple inches in diameter, a 50 millimeter or 70 millimeter telescope, you can probably just begin to see that it's a disk instead of a point of light. But if you use a telescope of 6 to 8 inches in diameter, you'll be able, at high magnification, to not only see that it's a disk, but you'll be able to make out some features. Right now, with a small telescope like that, you'll be able to see that there is a bright, whitish polar cap on the north edge of Mars. And you can see darker areas that look kind of bluish or greenish against the orange. And they're not really bluish or greenish, but the contrast with the way color works with a bright thing like Mars is that when you have a bright orange background, which is most of Mars, anything that's superimposed on it will have the opposite color, and the opposite color, what they call it, sometimes called the complementary color. Like the complementary color of red is green, and the complementary color of yellow is blue, and so on. So when you look at orange Mars, you tend to see the darker areas as bluish or greenish.
Okay. All right.
But they're really not bluish or greenish. But it doesn't matter. We don't need to argue about what the real color is because color is so subjective.
That's very true. Yeah. Is there anything happening on Mars right now that we should be looking for?
Well, yes, there are. First of all, we're right now at the kind of the onset of the cloud season, and the Mars northern spring began on November 11th. So, and understand that Mars's seasons are about twice as long as Earth's. So Mars is going to stay in northern spring until May. And so during spring, the North Polar hood, which was made of water ice clouds, has dissipated. It's gone. And so that means that water that was in those dense clouds has to distribute itself elsewhere on the planet. And it makes clouds appear in other areas of the planet that didn't have clouds, because most of the atmospheric water was concentrated in the North Polar Hood, and that is the clouds over the North Polar Cap, and in the North Polar Cap itself. Now, the North Polar Cap will be shrinking over the next 5 months. It shrinks essentially during the entire northern spring and gets down to a small size. And right now, the cap is tilted somewhat toward us so we can see it, and it'll be tilted somewhat toward us until the summer solstice. So we can see the cap, and it's going to shrink. And you may not notice it from night to night, but from week to week, you may notice it. Certainly from month to month, you'll notice it prominently as it shrinks. And it's because the sun is shining on it, and it's sublimating due to the sun and the warming as northern summer approaches. So when that happens, it's it's not only that we get clouds elsewhere on Mars, but we see particular patterns of clouds that are very interesting, and they're fascinating to see that you saw one in a telescope. There are clouds over the huge volcanoes on Mars, and these are well-known: Olympus Mons, Arsia Mons, Pavonis Mons, and Ascraeus Mons, and Elysium Mons. And there are some other volcanoes that also get identifiable cloud patterns. There's I think it's the Cerulus Mons and Hecates Tholus and so on, and we see clouds over those areas. But there's a peculiar pattern of clouds in the Martian late afternoon that forms in the Tharsis area of Mars, where there are many volcanoes. And we call them W clouds, and we seldom see the whole W pattern of this huge cloud array, but sometimes we do. It's a little challenging to see because it's only visible in the late Martian afternoon, which means that that particular area of Mars has to be in the late afternoon at the time you're looking at it. And Mars doesn't like to do what you want it to. In other words, when you look at Mars, you're likely to see the late afternoon, some area on the opposite side of Mars, and it has to be the right area of Mars for you to see this.
That's very true. Yeah.
Yeah. So, and there's another difficulty, and that is that when Mars is really easy to observe, like it's in our evening sky. It's after opposition in the evening sky. You can go out on a dark night and before bedtime, look up and there's bright Mars. At that time, you're looking at the sunrise edge of Mars. And the time when these clouds are visible is in the sunset area of Mars. You see, just before sunset. And it's not visible when Mars is in the evening sky. So, it just makes everything a little more difficult. You want to look at when Mars is in the morning sky to see these clouds, because then you're looking at the sunset side of Mars. But if Mars is not in the right time of its orbit, that is, if it's not northern spring, when this, as I've said, it's the cloudy season, we might have this morning time observation of Mars might not be during Martian northern spring. And so then you won't see those clouds, you see. So we don't see them with every orbit of Mars. And it turns out that right now, because it's near opposition, we see the whole face of Mars.
Right.
And we're beginning to see those clouds just in the late afternoon area of Mars when that late afternoon area is the Tharsis Mountains, the volcanoes.
Okay. Yeah, I've looked at some recent images of Mars, and it looks pretty clear. I mean, like you might have like you mentioned, clouds occasionally, but like I'm used to years at opposition when we have these massive dust storms on Mars that ruin everything for everybody. But I don't see that right now.
Yeah, we had a few dust storms already that we've seen, and one of them will be in the upcoming ALPO journal.
Okay.
There's a report there of a very interesting dust storm, really, that arose along the edge of the North Polar Cap and headed southward, and they had very strong winds along the edge of this air mass. Actually, this is a storm from the north that heads southward, much as Arctic storms move southward across North America or across Asia. And the edges of these storms are very windy and stormy, and we experience that regularly when we get strong weather and big rainstorms or snowstorms when we get a cold front moving down from the north. And when that happens on Mars, the area, because Mars is very dusty, the area along the edge of the air mass is very windy, and it stirs up a dust storm. And often that dust storm makes a linear feature. And so when it stirs up the dust storm, we can see a streak of dust on Mars. And one of the ones that will be in the ALPO journal shows this peculiar shaped streak of dust. And then it shows, after that streak disappears, it shows a few other spiral patterns, a couple of spiral patterns of dust, just like we have with a cyclone on Earth. We have these spiraling winds. And we see that type of phenomenon on Mars. Most often with a dust storm, the commonest dust storms are just small spots of red dust that appear along the edge of the polar cap. And we see those very often, and they are storms. This is stormy weather on Mars, unusually strong winds in a storm that stir up a lot of dust. So we see a sort of a red patch because of the reddish dust on Mars.
Interesting. Huh. So what type of observations are you looking to receive this year?
Well, most observers are making images. Okay. And nowadays, they do what we call lucky imaging. And not everyone uses that term. Some people still call it webcams and stuff. But lucky imaging is the term that's used in the professional literature to describe the idea of making essentially a video. So you get many very rapid images, and you use some software that judges those images according to their contrast or their quality or their clarity. And so the range of contrast in an image is related to its sharpness. And so it chooses the software chooses the sharpest of thousands of images. And then it takes the sharpest ones and it stacks them on top of each other so you get an average of the sharpest images. And the details of this procedure are controlled by the operator of the software. So you can do it according to your own preferences, and your preferences will depend upon your instruments and where you live, the type of what seeing conditions you're in, and so on. So each observer has his own methods, and that's a good way to do things.
Yeah, we recently did a webinar on Zoom for the ALPO with a gentleman that created lucky imaging software, and that's also available on our YouTube channel. Anybody could sit there and watch the presentation. It was very, very interesting.
Yeah, and that was just a couple days ago, and unfortunately, I missed that.
Well, you can watch it on YouTube. It's sitting right there.
I need to see it. Yeah,
it was very good. So, what about, do you get drawings too as well, or?
We get some drawings still. Okay. I think some Mars artists do impressive work. There is a real pride in seeing Mars visually. It's very distinct from the pride that you have in making an image. Either one can be a source of pride and accomplishment.
Right.
But there's a special type of feeling you get when you see it with your eye instead of looking at an image.
Mm-hmm.
And many observers will spend hours at the eyepiece,
Oh, yeah.
And they really do that well. And I'll name Paul Abel in England. Mm-hmm. He's just amazing drawings, and some of his drawings seem to be show detail comparable to images.
Yeah, definitely.
Yeah, and there are another couple of really good ones. I just shouldn't start naming names.
Yeah, there is something magical about visually observing and waiting for those moments when the scene stops and you get a crystal clear image on your eye of the planet Mars or Saturn or Jupiter, or any one of the planets too, as well. It's just, it's a magical moment. It's a reason you sit at the eyepiece for hours. It really is, to wait for those seconds.
Yeah.
Very true. Now, with visual observing, color filters, I'm sure, are a big part of observing Mars.
Yeah. And actually, they're a big part of observing, whether you're observing visually or with imaging.
Very cool.
But particularly if you use a filter that lets only light that's far into the blue, that blue light is where you see the clouds best. Right. And the reason is that since Mars is reddish overall, you cut out the overwhelming red light and you just see the blue light that's reflected toward Earth by the clouds, and it makes the clouds stand out. And that's really useful if you're interested in observing cloud phenomena on Mars. You want to have a blue filter. Now, the one that I recommend for most observers who are looking for clouds on Mars is an old-fashioned filter called a W47. Mm-hmm. The W stands for Ratten, W-R-A-T-T-E-N. That was a maker of filters in the early 1900s that was bought out by the Kodak company. Right. And those companies are now defunct, but the filters are, off patent, and they're made by a variety of companies.
Yeah. And the filter number is pretty consistent all throughout. I mean, that's right. And a 47 is really a dark, almost violet filter too, isn't it?
Yes. But the 47 matches the blue cone of your eye very well. In other words, the sensitivity, the transmission range of the W47 filter matches the sensitivity curve of the human eye, of the blue cone in your eye.
Okay.
And so it really is good in that way, good match for you. And it will show the clouds on Mars, but you won't see the other bright and dark features, surface features with it. You may see them occasionally, but generally you won't see them at all. And because those features just don't show up in blue light.
Yeah, I have not tried the 47 on Mars. I'm colorblind, red and green, so I have to juggle what filters I use, when I'm looking at different objects. So it's a whole different world for me.
Well, I've never actually looked into the commonest color blindness, which of course is we call red-green color blindness.
Right.
But I've never actually looked into that to see what filters would be best visually on Mars. So I wish I could tell you more about that. You'd think as a physician I would know about it, but it takes a little study.
Oh, yeah, it does. And trust me, I've experimented with every single filter there is just to try to bring out consistency from what other people see. And sometimes it's difficult. It really is.
Yeah.
Wow. So in the Mars section, if people want to do observations, you have observing forms that they can fill out and submit them, or?
Yes. And if they want to, particularly if they want to observe visually, the observing forms are quite helpful. Mm-hmm. And those are available on the ALPO website. If you go to the Mars section on the ALPO website, you'll see a heading for observing forms, and they have also not just the blank forms, but an example of a form that's filled out to guide you in filling out the forms.
Great. Is there anything about this apparition that you're excited about or want to share with our listeners?
Well, let me say that I think that there are a couple things about this apparition that are important to understand. Firstly, it's unusual to have such a good time, such a good opportunity to watch and record from night to night the shrinking of the North Polar Cap. This, you seldom see it this completely through this apparition. And by apparition, I mean, from the time that Mars was near the sun to the time Mars goes through the night sky until it's near the sun again, that we call an apparition. And during this apparition, the shrinking of the North Polar Cap, starting now, or starting actually a month ago, is perfectly positioned to watch it for the next many months and watch it shrink from night to night,
Fantastic.
And the other thing is a little bit disappointing about this apparition, and that is that not only is Mars a little distant, this is what we call aphelic. That means far from the sun. This is a far from the sun apparition. Apparition. It's heading out toward the far side of its orbit, where it's farthest from the sun. But also, in such an apparition, the clouds are just not available to us as well as we'd like it to be, and it's the geometry of that is a little difficult to describe visually. It's easier to draw pictures for people to help them understand.
That's true.
But as I was mentioning earlier, that it's a little frustrating this apparition to get to see the clouds around the volcanoes of Mars. Although you can see them, from occasionally, you just have to be lucky. But in other apparitions, you can see them every night, practically.
Yep.
So,
well, great. I'd really invite our listeners to go out there and observe Mars, and whether you do drawings or images, send them off to Roger, and he can get included in his apparition report in the journal in the coming year.
Yeah. One more thing I would say is that if you get to know Mars the way you might get to know the moon, that as you observe it enough that you recognize the surface features and you can identify clouds and so on, it really becomes very interesting.
Oh, yeah.
And you want to, just to see what you can see on Mars, will just make your heart beat a little faster. It's really cool.
That's very good.
Just imagine how 100 years ago, professional astronomers observing Mars were doing original research back then.
That's true.
And it was so exciting, and the whole world was excited about Mars. So excited that Percival Lowell believed that there must be intelligent life on Mars.
Yeah.
So
he saw canals on Mars. Yeah.
Yeah, and the bottom line about it is that Mars can be very interesting, and if you really were to observe it a good bit and get to know the surface features, it'll really be an eye opener for you.
And there's a challenge to our listeners: get out there and observe Mars, and spend some time visually looking at the planet and learn it. Grab yourself a Mars map and try to identify the features, where you're looking at, what side is facing the Earth at this current time. There's software out there to do that as well. So, yeah, I mean, it's an ever changing landscape, and that's what's beautiful about observing the planets.
Yeah. A lot of planetarium software, that shows you the night sky, will show zoomed in images of Mars.
Right.
Just as it will of the moon, with the proper face of Mars facing you, so that you can actually see in the software what you might expect to see on Mars.
Exactly. Well, Roger, this has been great. I want to thank you for coming on the podcast today.
My pleasure.
All right. Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Roger Venable for coming on and giving us a very entertaining talk about the planet Mars. Hey, get out there and observe Mars, this apparition. You'll love it. We'll upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please give us a rating and a review. I'd really appreciate it. You can also listen on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and also on the ALPO YouTube channel. You can help support the podcast by donating to it via Patreon, where you can give up to $35 a month, where you receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the producer of this podcast, Steve Siedentop and Michael Moyer, for their generous support. The link for Patreon, as well as the link for the ALPO, is in the show notes. If you'd like to get a hold of me, my email address is commentman@commentman.net. Until next time, I hope that you always have clear and steady skies. Thanks for listening.